Good morning, class! It's nice to meet you all again. Have you eaten your breakfast this morning? Oh, very good, because today we will have another new lesson for you to ponder and to learn. Are you all ready? Oh, since that you are all excited, please group yourselves into two. So the group 1 will be on the left side and the group 2 will be on the right side. Okay? I group you into two because we will have an activity. This is to determine the message inside the table. To do this, evaluate the polynomial at the given values of x. Then determine the letter that matches your answer. Okay, but before we start, I just want to clarify that the first group who will get the correct answer in each values of x will get 1 point. Okay? So let's start. Find the value of p of x if the value of x is negative 2. Go! So the correct answer is negative 3. So the group 1 got the correct answer. So the answer matches to letter C. Next, find the value of p of x if the value of x is negative 1. Go! Okay, what is the correct answer? Okay, 2. Group 2 got the correct answer. And the letter that matches your answer is in letter O. Here. So, find the value of p of x if the value of x is 0. Go! So, what's the correct answer? 3. So, group 1 got the correct answer. So, the letter that matches your answer is M. Find the value of p of x if the value of x is 1. Go! So, the correct answer is 6. So, group 2 got the correct answer. And the letter that matches your answer is in letter T. Next, find the p of x if the value of x is 2. Go! So, what's the correct answer? 17. So, group 1 got the correct answer. And the letter that matches your answer is in letter A. 17. So, the message that we get is compassion. Have you enjoyed our activity, class? That's good. That activity we did is a simple introduction to our topic today, which is about the remainder theorem and factor theorem. The remainder theorem is an approach of Euclidean division of polynomials. According to this theorem, if the polynomial p of x is divided by x minus r, the remainder r is constant and is equal to p of r. Thus, there are two ways to find the remainder when p of x is divided by x minus r. That is, substitute r in a given polynomial expression or use synthetic division. Let's have our first example. Using remainder theorem, find the remainder when 5x squared minus 2x plus 1 is divided by x plus 2. The first thing we gotta do is to get the value of our divisor, which is x plus 2. Let's equate it by 0. X plus 2 equals 0. So the value of our x now is equal to negative 2. Substitute the value of our x to our dividend. So we have p of negative 2 equals 5 times negative 2 squared minus 2 times negative 2 plus 1. Let's simplify. P of negative 2 equals 5 times 4 plus 4 plus 1. So we have now 20 plus 4 plus 1 is equal to 25. This will be our remainder. Let's find the remainder using synthetic division. Find the remainder when p of x equals 5x squared minus 2x plus 1 is divided by x plus 2. Like in our remainder theorem, the value of our x is equal to negative 2. Then let's get the value of our numerical coefficients in our dividend. So these are 5, negative 2, and 1. After that, bring down 5, then multiply to negative 2. So we have now negative 10. Then add negative 2 plus negative 10 is equal to negative 12. Negative 12 multiplied to negative 2 is equal to 24. So add them, 1 plus 24 is equal to 25. So the last term in our quotient is our remainder. Thus, the remainder when p of x is equal to 5x squared minus 2x plus 1 is divided by x plus 2 is 25. Let's have number 2 example. Using remainder theorem, find the remainder when p of x equals 2x raised to 4 plus 5x cubed plus 2x squared minus 7x minus 15 is divided by 2x minus 3. The first thing we gotta do is we get the value of our divisor, which is 2x minus 3, and equate it by 0. So we have 2x minus 3 equals 0. Then the value of our x will be 3 halves. After that, let's substitute the value of our x to our dividend, such as p of 3 halves equals 2 times 3 halves raised to 4 plus 5 times 3 halves raised to 3 plus 2 times 3 halves raised to 2 minus 7 times 3 halves minus 15. Let's simplify. P of 3 halves equals 2 times 3 halves raised to 4 is equal to 10.125 plus 5 times 3 over 2 raised to 3 is equal to 16.875 plus 2 times 3 halves raised to 2 is equal to 4.5 minus 7 times 3 halves is equal to 10.5, then minus 15. So we have now 31.5 minus 25.5. Then our remainder will be 6. Let's find the remainder using synthetic division. When p of x equals 2x raised to 4 minus 5x cubed plus 2x squared minus 7x minus 15 is divided by 2x minus 3. So to get the value of our x, let's equate our divisor by 0. So now the value of our x is 3 halves. After that, we will get the value or the numerical coefficients of our dividend. These are 2, 5, 2, negative 7, and negative 15. Next, bring down 2, then multiply to 3 halves. 2 times 3 equals 6 divided by 2 is equal to 3. Next, add 5 plus 3 is equal to 8. Then multiply. 8 times 3, 24 divided by 2 is equal to 12. Then add 2 plus 12 is equal to 14. Then multiply. 14 times 3 is equal to 42 divided by 2 is equal to 21. Then add negative 7 plus 21 is equal to 14. Then multiply. 14 times 3 is equal to 42 divided by 2 is equal to 21. Then add negative 15 plus 21 is equal to 6. So the last term in our coefficient is our remainder. Thus, the remainder when p of x equals 2x raised to 4 minus 5x cubed plus 2x squared minus 7x minus 15 is divided by 2x minus 3 is 6. So class, how do you find our lesson about remainder theorem? Do you find it easy? Oh, very good. So now I have here last item for you to answer. So take down in your activity notebook. Find the remainder when x squared minus 3x plus 7 is divided by x plus 5. I will give you 5 minutes to answer this. You can use either remainder theorem or synthetic division. Okay? So class, what is your remainder? So the remainder is 47. Who got it right? Wow, almost you got it right. So it means that you learned to our lesson about remainder theorem. So let's proceed to factor theorem. Sometimes the remainder when p of x is divided by x minus r is 0. This means that x minus r is a factor of p of x. Equivalently, p of r is equal to 0. That is the factor theorem. There are two parts of the proof of the factor theorem. Namely, in a given polynomial p of x, if x minus r is a factor of p of x, then p of r is equal to 0. Then, if p of r is equal to 0, then x minus r is a factor of p of x. Let's have our example number 1. Using factor theorem, show that x minus 1 is a factor of 3x cubed minus 8x squared plus 3x plus 2. So, let's get our divisor and equate it to 0. Then, the value of our x now is 1. So, let's substitute the value of our x to our dividend. So, here we are, p of 1 equals 3 times 1 raised to 3 minus 8 times 1 raised to 2 plus 3 times 1 plus 2. Simplify. 3 times 1 is equal to 3 minus 8 times 1 is equal to 8 plus 3 times 1 is equal to 3 plus 2. Then we have now negative 5 plus 5 is equal to 0. So it means that x minus 1 is a factor of 3x cubed minus 8x squared plus 3x plus 2. Let's have number 2 example, which is if one of the numerical coefficients is unknown in a given polynomial. Find the value of k for which the binomial x plus 4 is a factor of x raised to 4 plus kx cubed minus 4x squared. According to the factor theorem, if p of negative 4 is equal to 0. So let's take that the value of our x is negative 4. And let's substitute it to our dividend. P of negative 4 equals negative 4 raised to 4 plus k times negative 4 raised to 3 minus 4 times negative 4 raised to 2. Then, we will simplify. P of negative 4 equals negative 4 raised to 4 is equal to 256 minus negative 4 raised to 3 is equal to 64k minus negative 4 raised to 2 is equal to 16 times negative 4, that is equal to negative 64 equals 0. So now, let's transfer negative 64 to the other side to become it positive. So now, 256 minus 64 is equal to 64k. Then, we have here 192 equals 64k. To find k, let's divide both sides by 64. So our k is equal to 3. Let's check whether the answer is correct using synthetic division. To divide p of x equals x raised to 4 plus 3x cubed minus 4x squared by x plus 4. To get the value of our x, let's equate our divisor by 0. So now we have the value of our x, which is negative 4. Then, let's get the numerical coefficients of our dividend, which are 1, 3, negative 4, and let's put 0 to those two missing terms. Then after that, bring down 1 and multiply to negative 4, which is equal to negative 4. 3 plus negative 4 is equal to negative 1. Negative 1 times negative 4 is equal to 4. Negative 4 plus 4 is equal to 0. Then now, we have here that the last term in our quotient is our remainder. So this means that the remainder when p of x, which is equal to x raised to 4 plus 3x cubed minus 4x squared divided by x plus 4 is 0. So I have here your 5-item test for you to answer in your activity notebook. Also, your assignment to be passed on our next meeting. Okay, class? So, let's take a goodbye. Class dismissed.